So we are going to go over adding and subtracting fractions, and I have help from my son today. So if I were asked to identify like denominators from my fractions, or another way of saying it is common denominators, can you help me out? What would I look for?
Well, you would look for the common denominator. So basically the same number in the denominator section.
All right, so do you see anything in this list of fractions?
I actually see two pairs. So
Okay,
one pair would be 6 over 5 and 8 over 5. And I know they are common denominators because they have the same number, 5. And the numerator doesn't matter because the directions ask us to find a like or common denominator.
okay,
And then 9 over 8 and 3 out of 8, 3 eighths.
okay,
These will also be like denominators.
okay, good job.
Yeah,
All right, so by default then, which of the fractions have unlike or uncommon denominators?
5, 5 over 2 and 3/7
And why?
because they have nothing in common.
What do you mean they have nothing in common?
Their denominators they don't have the same ones.
All right, so which one is denominator again?
The denominator is always the bottom one.
The bottom number?
Mm-hmm.
Okay, so they're not alike, gotcha.
Got
All right, so let's go ahead and try example 1. So for example 1, what are we asked to do?
We are asked to add fractions with a common denominator.
All right, so can you explain to me what you would do if you saw this problem?
So basically what I would do, since they already have common denominators, aka the eights, I would just add 9 plus 3.
Which is?
12. So that would be 12 over 8.
So wait, I don't have to add 8 plus 8?
Nope, because they're already common denominators.
Gotcha, okay. So I see over to the side, I have simplify or reduce. So what would I have to do to simplify or reduce this 12 over 8?
Well, since simplify/reduce means go smaller,
Mhm.
I have to find something that I can divide. I have to find a number that we can divide by 12 eighths.
Okay.
So I would go with 4 because 8 divided by 4 equals 2 and 12 divided by 4 equals 3. Now I know that sounds like it doesn't make sense, but since they're both able to be divided by that, that's why I picked it.
Okay. That is the greatest common factor between both 12 and 8. So you were on the right track. Good job.
Yay.
Okay. Example 2, what are we doing?
We are subtracting fractions with a common denominator.
Okay.
Again, it's easy, and we would do the same thing with the adding thing, except we would take away.
Okay.
So 8 minus 6 equals 2, and then I just bring over the 5.
What do you mean bring over the 5?
In the denominator section.
Oh, okay. Can I simplify 2/5?
No.
All right, then we are finished. Let's move on to example 3. So for example 3, there's 2 ways that you can do it. Well, there's probably more, but I'm only going to talk about 2 ways. So what are we doing what does the directions ask us to do?
So the directions ask us to add fractions with a uncommon denominator.
Okay, so what would you do?
Okay, so what I do, since this is a little bit tricky, I have to first figure out what the denominator will be. So the denominator, I have to see what I can multiply to get it to be the same number.
To be a common denominator? Okay.
Yes. So 2 times 7, and I'm doing this because 14 is the same, can be each
7.
other number can be multiplied by the other number.
Okay. So one denominator can be multiplied by the other. So you're saying like 7 times 2 and 2 times 7?
Mm-hmm.
Okay.
So 7 times 2 equals 14, and 2 times 7, which is just flipped around, is also 14.
Gotcha. So what do I put in the numerator?
So we have to do the same thing that we did with the denominators and multiply it by that number. So
All right.
5 times 7 equals 35. And 3 times 2 equals 6.
Okay.
And then both of those equal 41. Now we cannot, over 14.
Okay.
Now we cannot simplify or reduce this because there's no number that will get us the same, the equal number.
Okay, so I can't divide 41 or 14 by a factor, by the same factor.
Unless it's 1, no.
Unless it's 1, and then it will just be itself, right? So what I noticed is over here, you multiplied by 2 in the denominator. So you went above to the numerator and you used the exact same number. And then on the second fraction, you multiplied times 7. And on that numerator, you also multiplied times 7. Okay, so I see what you did there. And at the bottom, so it leads into my strategy. So basically my strategy is just me. I like to draw circles and pictures. So what I'm going to do is for my step 1, I'm going to multiply my denominator, which is going to give me 14. My step 2, I'm going to multiply the numerator of the first fraction times the denominator of the second fraction. So 3 times 2 is 6.
Oh, the butterfly method.
Right. And then the operation that's in the middle is a plus sign. And now I'm going to take the denominator of the first fraction and multiply it times the numerator of the second fraction. So like you said, it kind of looks like a butterfly if you want to just go ahead and do that. Well, yeah, never mind. 7 times 5 is still 35, right? Which results in the same answer that you just said, 41 over 14. So it's always good to know that there is more than one way to solve your math problem. So it just depends on what your directions specifically ask you to do.
Or what your teacher specifically asks you to do.
Exactly. So make sure you understand that. And then the last example, I'm just going to go ahead and explain this one as the least common multiple. You could do it the same way that I just did it, which I'll show you for those people who want to do it that way. But the least common multiple is when you're looking at your denominator. If like say for instance, this 9, if 6 is not a factor of 9, then I can't use 9 as my common denominator. I could just multiply 9 times 6, like I said, which I'm going to show you in a minute, but that's going to be a big number. So if I'm using my least common multiple, what I want to do is set up a table, which I showed here. So LCM, you will see that in directions sometimes, it means least common multiple. All right, so I have a 6 in my second fraction as a denominator, so that's what I'm using here. And then I have a 9 in my first fraction, so that's what I'm using here. I'm setting up a table. I want to multiply each one of those numbers by 1, 2, 3. And sometimes you can go on even further, but I think, well, I know 3 is big enough. So 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18. And then I go to my second row and I do the same thing. 9 times 1 is 9, 9 times 2 is 18. Least common multiple means what is the smallest number when I multiply by something that they have in common. So least common, and I see is 18. So that tells me that's going to be my least common denominator. So I know that this is going to be 18. Now I can use the method that my son just told me. 9 times what will give me 18?
9 times 2.
So whatever I do to the denominator, guess what? I do to the numerator. So 12 times 2 is going to give me 24. I take the sign that's in the middle, which is subtraction. And 6 times what will give me 18?
6 times 3.
Okay, so notice I don't have to use the same number in both my fractions. So 6 times 3 is 18. So therefore my numerator is 5 times 3, which is 15. Now, when I am subtracting, 24 minus 15 is 9. 9
Okay.
over 18. Now, looking at that, can you see whether or not I can simplify that, or do I just leave it like that?
Um, you can simplify it. It looks like it.
Okay, what can I divide both the top and the bottom by, the numerator and the denominator?
My bad. You cannot simplify it.
Yes, you can.
You can.
Mhm.
The
Look at my table.
oh, divided by 3.
Look at my table.
2 divided by 2.
Right, and the reason you said 3 is because you're looking at this one. That's 6. This is 9, okay?
Oh, my bad.
That's okay. I know I put you on the spot there. So for anybody who's trying to simplify, what you want to look at first is your smallest number out of the two numbers that you have and see whether or not you can divide both of those by that number. If you can, that is the number you're dividing by. Did that make sense?
Yeah, kind of.
All right, so that means I'm going to divide both my numerator and my denominator by 9 because that's my greatest common factor between the numbers 9 and 18. When I do that, what's 9 divided by 9?
9 divided by 9 is 1.
18 divided by 9?
That's 2.
2. So my answer in simplified form is 1/2 if you use the least common multiple method. If you use that other method that I was showing you a few minutes ago, the butterfly one, what was it? 12 over 9 minus 5 over 6?
Yep.
You can still use this. It just might confuse some people because the numbers are big. So the first step again is to multiply the bottom, which is 54. Second step is to multiply the numerator of the first fraction and the denominator of the second fraction. So 12 times 6, which is 72. My operation tells me to subtract, and then I go to my numerator of my second fraction and my denominator of my first fraction. 9 times 5, which is 45. And see how these numbers are big numbers? They still work, but 72 minus 45 is 27 divided by 54. And this is where you need to know your multiplication table or your factors, basically. So what I would want to do in this case is I would want to find the factors of 27 because that's my smaller number between the two, 27 and 54. So those factors are 1 times 27 and 3 times 9.
Hey, Mom.
Hold on.
Okay.
So 3 times 9. And then what you want to do is you want to, out of those numbers, what's the biggest number, so greatest common factor that I can divide both the 27 and the 54 by? Always start with your biggest number. So if you divide 54 by 27, yeah, I know that's a huge number. It's going to be 2. So I'm going to divide both of these by 27. And that's 2. Well, 27 divided by 27 is 1. So you still end up with the same number that you had a few minutes ago. That's just a different way of doing it. So what were you going to ask me?
I was thinking with the butterfly method, I kind of came up with something on the spot. I don't know if it necessarily works.
Okay.
But as you have showed, I was gonna do like, okay, you circle the bottom first, so that would be B for bottom, and then you would do the top. Oh wait, no, you would do the diagonal, so left diagonal, and then L for left, and then you would do the right diagonal, so R for right, and then I would say bike, let's ride. Does that work?
Okay, bike, let's ride.
Does that kind of work?
You are my child. I do this in class all the time. I just make up random stuff and it helps my students remember. So thank you. So we're going to end the video and I appreciate my son's help. Everybody, let's give this video a like.